Welcome to the third video of the time complexity series. In this video, we'll go in depth on linear time complexity as well as why constant factors do not affect big O notation in linear time complexity either. Let's get started. Remember, linear time complexity just means that the runtime of our algorithm is directly proportional to the input size n. While you can see here that it says directly proportional, and this can easily be mixed up with equal to. Remember that directly proportional does not always mean equal to. So the input size n does not always equal to the number of computations. That's just a note for later when we get into why constant factors don't affect our growth rate. And remember, linear time complexity is denoted by big O of n. And yeah, let's get into an example. So let's say that we have a function that prints hellos. Remember in the last video, the constant time complexity, this did not depend on the input size. In this one, it'll depend on the input size. Range and input. And let's do print hello world. So as you can see here, our function just prints hellos the number of times based on the length of the input array passed in. So let's make two arrays to test this, and then we'll do list comprehension. We'll do range 10, and then in the second one we'll do range 100. So we'll have two different input sizes, and to use this we'll just do print hello array 1. So this should just print the hello worlds 10 times, as you can see here, because our array is 10 elements long and it'll print based on the input size. But if we change it to the second one, let me clear the terminal right here, clear, and then we press enter, see how it prints 100. It'll print a bunch of times because it's 100. And array 2 is length 100, and that's why we print hello world 100 times. And you can see why this is denoted by O to the n, because our algorithm depends on the input size. So in this case, our algorithm is directly proportional or equal to our input size, but not in all cases. Let's move on to the next part. So the next part is that constant factors do not affect the growth rate of our algorithms. Remember in math class, if you took algebra or something, you'll remember that y equals mx plus b is our most basic form of a linear equation. And in big notation, the m and the b do not matter. And we can see this graphically. Let me go over to Desmos. So let's say we have two linear functions right here, y equals x, y equals 2x. As you can see, one is always going to be greater than the other, but these are both denoted by O to the n. And this is because, remember, O to the, or big O notation tells us the growth rate of our algorithms. And as you can see here, the growth rate of this is both linear because the input size is going to be directly proportional to the computational size. So here, y equals x, we can just think about it as the computations are equal to our input size, but here our number of computations is just going to be double the amount of the input. And that doesn't change the overall growth rate because these are both linear functions, which is why they're denoted by big O to the n. Remember, big O notation is just the upper bound of the algorithm's runtime. And to run this, or to do an example of this, we can do, let me think, what example should we do? All right, I see. Let's just do the hello world example again, but this time, let's make it a little different. Let's do def print hellos, and then take the same input, and then let's just copy and paste this. So we have that. And then let's just copy paste it again. So here you can take a guess. It'll just print hello world double the amount of times that we did last time, which makes it 2n. And then to print this, let's just bring the arrays from up here. Perfect. So I'll just make this one 1 and this one like 5, so my terminal doesn't get cluttered. And yeah, let's use this function on array 1 on command. Okay, now you can see that it prints out hello world twice, so it just prints out double the amount of our input size. And if we use it on the other one, it should just print out 10 times. There we go. Yeah, so this is O to the 2n. And O to the 2n just means that the number of computations is just going to be double the amount of input size, as we can see here. But in big O notation, that factor does not matter. So we'll just denote this by O to the n, because our number of computations are directly proportional to our input size. And that's what linear time complexity is. Thank you.